Hello. So this is the second part of lesson 5.1. So the first part was the simple interest. Now we're going to talk about compound interest. So the difference between these two, simple interest is earned on original amount. Compound interest is earned on your previous balance, both the original amount and earned interest. Okay, compound interest formula is going to be the future value equals the present value, parentheses, 1 plus I to the power of n. So FV is the future value. Again, that is the same thing as the total, PV plus I, so present value plus interest. Actually, it should be here where the parentheses are. And then PV is the present value. Same thing as you might see principal. And then I is the interest rate per period. Now I is calculated by R over M. So R is the annual interest rate in decimals. And M is the compounding periods in a year. Okay, we've got I, we've got R, we've got M, and then N is the number of compound periods. N is the same thing as M, so the compounding periods in a year times T, and T is the time in years, just like it's been. Okay, so this is your compound interest formula. Again, it will be given on the exam, and it is on the formula sheet that is on Canvas. So you don't need to memorize it. Okay, let's practice. So find both the future value and the interest earned, rounding to the nearest cent. Okay, so what do we have here in this first one? We've got our present value, which is $15,000. Our interest rate is 3%, so 0.03. Our T is 19 years, and it says annually, that is our M, which is the compounding periods in a year, and that is a 1 because it's annually. Okay, now we're going to calculate the I. So the I is the same thing as the R, which in this case is 0.03, divided by M, which is 1. So our I is 0.03. Our N is going to be M times T. So our M is 1 because it's annually, and our T is 19. So this is going to be 19. Okay, so let's get the future value. So our present value is $15,000. times 1 plus 0.03 to the power of 19. And when we do this calculation, we get $26,302.59. So that is our future value here. Now, it's asking to find the interest earned. So remember that future value is the present value plus the interest. Now, when we need to find the interest, we're going to take the future value, so $26,302.59, and subtract our present value from that. So 15, oops. So $15,000. And that equals $11,302.59. Okay? Next one is going to be the same amount. So our principal value is still $15,000. Our rate is the same. 3% is 0.03. Our T is still 19 years. Now the difference is that it is compounded semi-annually. So our M is going to be 2 because it's compounded twice. Okay, so let's look at our I is going to be the rate 0.03 divided by the M, which is 2. So that's going to be 0.015. Our N is going to be M, which is 2 times again, 2 times a year, times the years, which is 19, and that's going to be 38. Okay, hold on, let me put it up here. Our future value is going to be 15,000 times 1 plus 0.015 to the power of our N, which is 38. Oops, that does not. I guess I looked away just as I was writing it. And so our future value is going to be $26,411.97. Interest earned is, again, we're going to take that future value, so $26,411.97, and subtract the $15,000 from it, and we get $11,411.97. Okay, so for both of these, this part is the same, and we can see already a difference when it's compounded 2 times instead of 1 time. Interest earned here was $11,300, and here it's $11,400. So let's see what happens when $15,000 is, the interest rate is again 3%, so 0.03, and our T time is 19 years, so that has not changed. So all of these are still the same. Now the difference is the quarterly compounding. So our M is going to be 4. I is 0.03 divided by 4, which for some reason I don't have that calculation here. 0.03 divided by 4 is 0.0075. That's probably okay. And our N is going to be M, which is 4 times, again, quarterly compounded in 19 years. And that is 76. Okay, our future value is the present value times 1 plus 0.0075 to the power of 76. Okay, so the future value is $26,467.65. So again, more than what we've got here. Okay, and the interest earned is going to be $26,467.65, and we are subtracting 15,000 from it, so the present value and our interest is $11,467.65. So we earned more interest again because even though the time was the same, um, we compounded it, you know, more times. Okay, we're gonna keep going. So $15,000 again, it's the exact same. Um, present value rate is 3% and T is 19. Now what is changing is the monthly. So our M is going to be 12 because it's going to be compounded 12 times. Okay, our I is going to be 0.03 divided by 12, and our N is going to be 12 times 19. I'm going to leave the I as it is because it's going to be a smaller decimal. 12 times 19 is 228. Okay, so our future value is going to be 15,000 times 1 plus, and now it's going to be 0.03 divided by 12 to the power of 228. And we get $26,505.15. So when we calculate our interest, 26,505.15 minus 15,000, we get $11,505.15. That is our interest. So again, this is more than what we had here. Okay, we're going to keep going, and now we're going to compound daily. So the exact same amount at 3% for the same. So our present value, our rate, and our time is going to be the exact same. Our M is going to be 365. Our I is going to be the rate, 0.03 divided by 365. And our N is going to be 365 times 19. Okay, so even larger numbers here with the 365 times 19, that is 6,935. Okay, so let's look at future value. Again, our present value, $15,000, has not changed. 1 plus, oops, I'm going 1 plus, and then we've got zero point 0.3 divided by 365 to the power of 6,935. And when we do the calculation here, we get $26,523.38. And our interest, again, when we do subtract, is $11,523.38. Okay, now questions. What happens to the future value and the interest earned as you compound it more frequently? Well, just like we saw, they both increase. Find the differences in interest earned as the compounding period increases. Is the change constant, increasing, or decreasing? Okay, so let's look at, you know what, I want to make sure that I'm not running into this here, so I'm just going to draw a line. Where's our m equals 1? So our m equals 1, this was our annual. And then we went into m equals 2. So that was semi-annual. Then we went into quarterly. And after the quarterly, we went into monthly. And then our next one was the daily. So when we calculate the differences between these two, so we're going to go and calculate the difference between the $11,302.54 and $11,411.97. So we're going to subtract the interests for those two. We get $109.38 more. So semi-annual was more. Now, when we go from semi-annual to quarterly and we calculate the difference again for the interest, we get $55.68 more. The difference between quarterly and monthly is going to be $37.50 more. And monthly and daily, it's $18.23 more. Okay. So if we look at the change here, it is decreasing. We're still getting more, but it's less. Like it's not $18.23 compared to here the difference was $100 and $109. Okay. So next we're going to look at continuously compounded interest formula. Again, we notice that the more we compound, the more interest we're going to get. The continuously compounded future value is the present value times e to the power of r times t. So if v is our future value, pv is our present value or principal, just like it's been all along. R is the rate in decimals. T is time in years. And then we have our E, which is the natural base. Okay, so let's go ahead and plug these in. So again, both the future value and the interest earned. Our present value is the same as we saw in the previous examples, $15,000. Our rate is the same as well, 3%, so 0.03. Time is 19 years, And again, notice that now we're compounding continuously. So let's look at what we get. $15,000 times e to the power of 0.03 times 19. When we plug that into the calculator, we get $26,524.01. Okay, interest earned, again, is the same thing. We're going to take that future value that we got and subtract it from, or subtract the present value from it. And when we do that, we get $11,524.01. So if we go back here and look at um, what we got when it was daily compounded, it's almost the same. The continuous is a little bit more. Okay. Next, now we're going to look at an application. So zero coupon bond. Um, or actually, we're gonna. Sorry, not an app. Well, these are all applications if you think about it. But this is just we're defining zero coupon bond just so that we know because we're going to be using it here. So ordinary corporate or municipal bonds usually make semi-annual simple interest payments to the holders. With this bond, however, there are no interest payments during the life of the bond. Instead, the investor receives a single payment when the bond matures, including his original investment, the interest earned, and compounded semi-annually. So it's asking to find the face value of the zero coupon 30-year bond at 6% sold for $2,546. Okay, so our present value is $2,546. Our time is 30 years. Our rate is 6%, so it's 0.06. And what else do we have? What do we have? So remember, this is compounded semi-annually, so our M is going to be 2. So we're going to go ahead and do I equals R over M, so 0.06 divided by 2, which is 0.03, and then our N is going to be 30 times 2, which is 60. Okay, so we're going to use the compound formula. Future value equals the present value times 1 plus I to the power of n. $2,546, 1 plus 0.03 to the power of 60. And we get $15,000 for that one. Okay, next, we're going to define what is a effective rate, RE, or annual yield, APY. The simple interest rate that would produce the same amount of interest in 1 year. There's no period yet. As the nominal, that is the stated, compound rate. So R with a subscript of capital E is the same thing as APY is 1 plus R over M to the power of M minus 1. R is the rate, M is the compounding periods in a year. Again, this formula is on the formula sheet. Okay, so let's practice. Find the APY corresponding to the nominal rate of 12% compounded monthly. So our rate is 12%, 0.12, M is 12. APY equals 1 plus 0.12 divided, oops, not divided by. The 1 is not, hold on, let me rewrite this. 1 plus 0.12. This is divided by 12 to the power of 12 minus 1, and that is 0.1268. This as a percent is going to be 12.68%, and it says 2 decimal places. There we go. Okay, next example. If inflation has been running at 3.75% per year, and a new car costs $23,000 today, so that is our future value. Because what it says is what would it have cost 3 years ago? So our time here is going to be 3. We don't know. It's asking for the present value. Our M is going to be 1. So with this, our I is going to be 0.0375 divided by 1. And our N is going to be 1 times 3 equals 3. Okay, on the formula sheet, you will find, again, the present value equals the future value over 1 plus I to the power of N. So let's plug the numbers in. $23,000 divided by 1 plus 0.0375 to the power of 3. And that is $20,595.08. So that's what it was worth 3 years ago. Or what it would have cost 3 years ago. Okay, we've got one more example here. So Win wants to have $20,000 available in 5 years for a down payment on a house. They have inherited $16,000. How much of the inheritance needs to be invested now to accumulate the down payment if they can get an interest rate of 5.5% compounded quarterly? So future value is going to be the $20,000. What else do we know? T is 5 years. Our rate is 5.5%, so 0.055. Um, hold on, where are we? Quarterly, that's what I was looking for. So M is 4 times a year. So our I is going to be 0.055 divided by 4. And our N is going to be 4 times 5 equals 20. Okay, so let's look at the present value equals the future value divided by 1 plus I to the power of N. So $20,000 over 1 plus 0.055 divided by 4 to the power of 20. And this equals $15,220. So that's how much money they need to um, invest. Okay, that's it for this lesson. Again, let me know if you've got any questions about it. Bye.